My name is April, and I am one of the volunteers for TMLS. Thank you for joining our bonus workshop session today. Some housekeeping information. Tomorrow, our conference begins on hopin.to, so we look forward to seeing you all there. This moment, I'd like to take to welcome our speaker, Aniththa, who is a program manager on Microsoft Azure Machine Learning team. Her latest mission is accelerating and democratizing artificial intelligence via automated machine learning. So we welcome Aniththa today. Thank you, and I'm going to pass it over to you.
Hi, everyone. My name is Aniththa, and I'm a program manager on the Azure Machine Learning team. And today we will be focusing on how you can simplify the whole machine learning process from ideation to deployment in minutes with Azure's automated machine learning. So since this is a workshop, I do want to make sure you get started with all the prereqs while we go through some of the slides. So to start off, I did paste a link to the GitHub repo where we would find all the material you will need for this workshop. So the first step that I would ask everyone to do is make sure you have an Azure subscription. And if you don't have one already, you could visit this link over here under the prerequisites. And this will take you to the create your Azure free account today page. And you could create a free one. You'll get $200 of credit and you'll have enough to run through this workshop today. So go ahead and create that. If you already have an Azure subscription, the next step you'll need to do is go ahead and create an Azure Machine Learning workspace. To do this, you'll need to visit portal.azure.com. So let me just show you from here. So go to portal.azure.com. And then from here, what you'll need to do is search for machine learning as a resource. So if you see here, there's create a resource. You could either search for machine learning by clicking on this, or if you see this right in the home page, you could click on that and go ahead and create a new machine learning workspace. And all the instructions to do those prereq stuff are right here in the under the section in the GitHub repo. So I recommend going through this while I start talking about what automated machine learning is. If you do have any questions, feel free to bring it up in the chat. I'll review it throughout the presentation. So let's go ahead and get started. So I'll tell you what's on the agenda for today. First of all, we'll start off with what is automated machine learning. I'll do a quick deep dive into the capabilities, and then we'll go through the product walkthrough. So there's two examples that I'm going to show you and once you have everything set up, you'll be able to run through those two examples with me during the session. So let's get started. So as we all know, data science is everywhere and it's almost touching every single industry. It can be simple as figuring out the price of a car or figuring out how much money to have in a bank. And we can't expect everyone to get a PhD in statistics and data science. And there has to be a way to simplify this whole ML process. So let's take a look at the machine learning process. We know that as a data science or a developer new to machine learning, I will need to first start off with the whole data featureization step. So making sure I clean up my data, make sure I handle any missing values, impute it correctly. And once my data is in a good place, I want to go ahead and choose an algorithm. And we know there's a lot to choose from, especially depending on the task type we're working with. And once we have our algorithm selected, we could go ahead and tune our hyperparameters. And usually this whole process is iterative as we need to continue to do this until we find that best model with the optimized algorithm, data selection, and hyperparameter values. So there has to be an easier way to do this. And that's exactly where automated machine learning comes in. So with automated ML, and we're talking about Azure Machine Learning's automated ML, as a user, all you'll need to do is bring in your data, identify the task type. So is this a classification problem? Is this a regression problem or a forecasting task type? And then from there, you could go ahead and apply some constraints. So maybe say you want to run this experiment for 3 hours. Maybe you want to end this experiment once your the model reaches an accuracy value of say 95%. Once you specify these constraints, what AutoML does is it intelligently tests multiple models in parallel, and it'll return that optimized model for you. For example, in this case, 95%. So I want to tell you what the goal of automated MLs, Azure Machine Learning's automated ML is. So the first thing is accelerate AI. So what we want to do is let's we want to make sure all our data scientists can be more productive. So we want to expedite the whole data science process for them. The second thing is democratize AI. So we want to make sure, let's just say you have a data science team with varying levels of experience. We want to make sure all users are able to build these machine learning models. So we want to make sure everyone becomes an expert. And finally, we have scale AI. So we have heard from customers where they want to build multiple models in parallel. Now, with automated ML, they can do that in an automated way. And that's why our mission is to accelerate, democratize, and scale AI. So what automated ML does, it chooses an algorithm for you, does all the featureization, and returns that optimized model for you, which you could further decide to deploy out or further customize. Now, we offer automated ML through both UI, which is what you see here, and we will definitely walk through that today during the workshop, and also through an SDK. So you could actually run it through notebooks. So whichever one you prefer, if you prefer to use code, you can use our Python notebooks. If you prefer to just quickly click through and get to an optimized model, you can use our UI. So how it works and what happens is basically automated ML is actually based off of Microsoft research. And I kind of like to think of it as using Netflix. So, for example, when you're using Netflix, you might watch a couple movies and you'll notice that under the recommendation list, you'll see that exactly what you want to watch next. And that's exactly how automated ML is recommending the models for you. The brain has been trained with several millions of experiments and uses collaborative filtering and Bayesian optimization. Some things that we like to call out is that we maintain the privacy of your data. So we are not looking at your data. We are only looking at the metadata in order to come up with the accuracy and all the metrics for your model. And currently, we only support classification, regression, and time series forecasting. So, just to tell you a little bit more about what happens behind the scenes when you launch an automated ML run. So, we start off with the data processing. We go ahead and impute these missing values for you, drop any high cardinality values or no cardinality columns, and do all of that imputation and keep your data ready. And then you will have to spin up a compute, and this is exactly where the training will be happening. And depending on your data and the model you're trying to train, you will need to choose a different compute, and it would automatically scale to your experiment needs. So another thing is we do some featureization. So you have the option to either customize your featureization or use the auto featureization, and we will come up with those engineered features for you. And finally, model trials. And what we mean by that is AutoML is not just returning one model for you. You get to see a summary of all the models that were explored. And you will get to see the metric values for those different models. And once we get to the demo part of this workshop, everything will make more sense. So we'll just dive right in. So the next thing that we're going to go over are the capabilities and what we currently support. Again, if you have any questions, feel free to bring it up in the chat. I will go over it in the end. So to start off, let's looking at the beginning of the machine learning process. It's the data, and what we expect when you're using automated ML is tabular data. And you have a couple of options of where you can bring this data from. It could either be a local upload, blob, data lake, and all the others that are listed on this slide. And then if you don't have a header or column name specified, we will go ahead and specify that for you. We do have large data support. And also, if you are looking to work on scenarios, for example, if you're forecasting sales or whatnot, maybe holiday data or weather data might have an impact on your predictions. And now you can take advantage of Azure Open Datasets to bring in that such data into your predictions and get better accuracies. We also do support data guardrails. And what we mean by this is we do check for class imbalance, train test split, CV rolling, missing value imputation, detect high cardinality features. We detect leaky features. We detect overfitting, model interpretability, and feature importance. And you could see this both from the UI as well as the SDK. So when you're running the notebooks. The next step is featureization. So we do support deep learning via BERT. Um, as I mentioned earlier, you have the option to either use the featureization step that is automatically done with automated ML, or you can customize it. So you have the option to impute it with mean, median, or mode, drop some columns, and there's a whole bunch of other things that you could do depending on whether you're running it from the UI or the notebooks. But again, it's optional to run the customized featureization. You could always leave it as is or turn it off completely. So that's basically featureization. Now, when it comes to training, as I mentioned earlier, we do support classification, regression, and time series forecasting. We have added additional forecasting learners, such as ARIMA, Profit, and a forecasting TCN model. These are quite popular, and you can use it along with our classical models that are already within automated ML. Also, another pretty cool feature is our many models approach for scaling out. And what I mean by this is, let's just say you have a scenario where you're trying to predict orange juice sales. When predicting sales, things like the store and the brand can have an impact on the model. So with our many models approach, you're able to group your models and build out these models in scale. So build multiple models in parallel. Um, with our many models solution accelerator, you could build tens, thousands, or even millions of models. And we are working on scaling out based on your experiment needs. If you have any scenarios for this, definitely reach out to me. I would love to hear from you on how we can support. I will also paste a link to our solution accelerator after this call. The next thing on our chart is interpretability. So once we have the whole training process done, we usually want to know what's happening behind the scenes, which features played an important role in the model creation process. And we do have our interpretability dashboard, where we support both global importance and local importance. And what I mean by this is when we're looking at our global importance, we're looking at all the features in our training data, and we see which ones impacted our prediction. So for example, if we're looking at employee retention or whatnot, the duration and our employed has an impact in these predictions. Now, if we're looking at local importance, we're looking at a single data point in our data set and seeing how it impacted our prediction. So I could see how it impacted Annie versus another person and compare the results. So this is exactly what I mean by explainability. And additionally to this, we also do support feature transparency. So you could see a chart of the engineered features that were created and how they were created, either through imputation or whatnot. So these are the things that we do to make sure the whole model creation process is transparent and you understand which features played an important role in the whole model creation. So now what I'm going to do is I'm going to dive back into demos. So if you do have your workspace set up and you already have your subscription, you can go ahead and follow along with me, or else just take this time to watch this as a demo and go ahead and try reproducing what I show you later on after this call. So I'm going to go ahead and open up my workspace. So we have separated this into two labs. Lab part one, where we're going to use the automated ML UI, and then lab part two, where we're going to use the Python SDK. Now, for lab part two, you will need to do this extra step where you're creating a compute instance. So remember to follow these steps one by one so that you don't miss anything. But over here under lab part one, we actually ask you to create the compute instance first so that you could go ahead and run everything smoothly. Here are the steps to create it, but I'll quickly walk you through it as well before I start lab part one. So I'm going to jump over to ml.azure.com. So I'm just going to close some of these tabs. So right now we are here at the Machine Learning Studio, Azure Machine Learning Studio. And this, you will have access to the workspace that you created as part of the prerequisites. So I'm gonna first quickly walk you through of what you see here on this page, and then I'll dive into some specifics. So this is the home page. You would see all your the authoring stuff right here. So you can use notebooks. So this is where you could use like Python code to train your models. We have the automated ML UI. So if you click on this, which we will in a bit, you could train models just with the click of a button. And then we also have the designer tool, which allows you to drag and drop to create your models. And then we have our assets, and these are the things that we're going to create along the way while we are setting up our models. This could be the data, the experiments, pipelines, models that get registered, and endpoints, as in the deployed models. And finally, we have some additional stuff such as compute, data stores, and data labeling. Today, we're only going to touch on compute, which is what we're going to be using to scale out this model training process. So in the instructions in the GitHub repo, it would ask you to create a compute instance. So I'm going to let this to load, but you could easily, there'll be a create new button once this loads. And you could go ahead and create one. Just follow the instructions in terms of what compute name. You could just give any unique name. Choose the same size as specified here because you won't really need anything large in this example. And then once you have that set up, it should appear as complete. So it will take at least like 5 to 10 minutes to load. So I'm just going to refresh my page so then you can see what it looks like. So okay, this is what it actually looks like. So you'll see that this is a compute instance. You see, in this case, I have this October 2020 and it's running. You could always go ahead and create a new one, and which is what I'm going to recommend for you, all of you who are creating it for the first time. And for this exam, like for lab part 2, we will be using this. But for now, let's go ahead and start with lab part 1, which is automated ML. So for this example, we are going to be using the bank marketing dataset, and this is a classification problem. And in here, we're trying to predict whether an individual will get a term deposit or not. So it's a yes or a no. So when you click on the automated ML tab, for you, it should be blank if you've never run an experiment before. What I see here is all my auto ML runs charted out their status, how long it took, and all those additional details. But let's go ahead and create a new automated ML run. So the first thing you'll need to do is go ahead and create a data set. Just a heads up, the instructions are going to be a little different from what I'm doing because I already have some of the steps set up already, but make sure to follow the instructions in the GitHub repo when you are doing this for the first time. So the first thing you'll need to do is go ahead and create a data set. So you have the option to do this either from local files, data store, web files, or open data sets. And in the GitHub repo, we do have the data set attached. So you could go ahead and download that locally and go ahead and attach it from local files. I'm going to go ahead and use this bank marketing data set that I uploaded earlier. And as you can see, it's in tabular form. And one thing you could do is also preview the data before you actually start your training process. So I could see this is what my data looks like. And in this example, I will be predicting on the Y column. And then I could also pull up some data statistics to understand my data better. So you could see, for example, age, the min value is 17, max is 94. And just to better understand what's happening with my data. Once I'm ready, I could go ahead and start configuring my run, which is what I'm going to do next. And the first thing I'll need to do is give my experiment a name. If you're starting this for the first time, you'll need to click on create new. I've done this before, so I'm going to go ahead and call it bank marketing. And then I'll need to choose the target column. So this is the column I'm going to be predicting on. So in this case, it'll be this Y column. And then I'll need to create a compute cluster. And this is how the whole training process is going to be scaled out. And keep in mind, the compute will automatically scale to your experiment needs. I'm going to go ahead and use a compute that I already created earlier. For example, this one over here. You will be required to create a new compute because you're doing this for the first time. I recommend following the instructions in the GitHub repo so that you use the exact compute specified in the repo. So once I have my run configured, I could go ahead and identify the task type. So as I mentioned earlier, AutoML currently supports classification, regression, and time series forecasting. And depending on the task type you choose, you'll see additional settings for you. For example, I know this is a classification example, and I have the option to enable deep learning. But if I did choose time series forecasting, I will need to specify like a time column or time series identifier. But I'm going to just stick to a classification problem in this case. And then I have the option to further tune my model, and I could do this through my additional configuration settings. So I could decide which primary metric I want to optimize on. So in this case, it's auto defaultly selected to accuracy, but I could always decide to use AUC weighted. I could decide to block some algorithms, or if I don't do this, all of the algorithms will be explored. I could specify some exit criteria. So I could say that I only want to run this for 3 hours. Maybe once it reaches an accuracy of 98%, please exit this job. So these are just additional things that you could do. For this example, I'm going to leave it the way it is. One last thing that I want to show you before we launch the run is our featureization settings. So this is how you create those engineered features. So right now, this is the auto setting, the default ones, but you have the option to either turn it off or you could customize it, like decide to include and exclude certain columns, choose a feature type. So for example, age will automatically be detected as numeric, but maybe I want it to appear as text. And you could also decide to impute it in a specific way. And once you're happy with it, you could go ahead and save those settings. For now, I'm just going to go ahead and launch this. And what's happening is now AutoML is intelligently testing those multiple models for us and going to return the optimized one. So while this run kicks off, I'm going to go ahead and show you what this looks like um, from a previous run that completed a little earlier. So let's open up this one. And it's still in the bank marketing experiment, and you could access all your experiments from the experiments tab. So right here, this is where you specified the name in your AutoML one, and I called it bank marketing. So I could go ahead and access that, and that's why I was able to open up an old experiment. And I could see from here, this is the models details page. I could see the best model summary. So this is the recommended model. In this case, it's voting ensemble. I could see it had an accuracy of 91%. I could also go ahead and explore the additional metrics just so that I could have a fair good idea of how it performed. Additional things is the data guardrails that I talked about during the slide. You can see that it detected all of these for us. For example, validation split handling. It alerted us about class balance detection. There was some missing feature value imputation and additional stuff. So you could just explore this, go ahead and launch another run depending on what is specified in the data guardrails. If I click on the models tab, this is where I could see all the models that were explored during this run. So in this case, voting ensemble was the best model, but also these models were here. So we had like the max ABS scalar, like GBM model, which had a 91% accuracy. And if we are not happy with the recommended model, we could always go ahead and explore one of these individual models. I'm going to stick to this voting ensemble for now. And the next thing I want to show you is explanations. So this is going to be the dashboard, which tells us which features played an important role in the model selection process. So right here, we're looking at the raw features, and we see that duration and our employed and EMP var rate all had an impact on the whether an individual will get a term deposit or not. And we could identify how many features we want to look at, 3, 4, 5. Another thing is we do also provide feature importance for engineered features. So we were looking at the raw right now, but I could switch it from by clicking on that tab here, and this will load it up for the engineered features. So now we see additional features that were created during the experiment. Another thing we could review is the whole local importance chart, which I want to show you quickly. So from the summary importance, I could click on an individual data point, and this will allow me, so like for example, I could click on this individual point, and this would open up the local feature importance for me. So for that individual point, these were the features that played an important role. So that's basically the explanations chart. And another thing that you could do is review the metrics. So we have all these metrics depending on the task type. So for example, since this is a classification problem, you would have access to a precision recall chart, and you could always explore the additional charts based on whatever you're looking for, and you can see all the metric values as well. So this is basically the metrics. And now once you're happy with your model, you could go ahead and deploy the model out. Just give it a name. You could identify if you want to deploy it out to Azure Container Instance. So this is a testing environment, or Azure Kubernetes Service, which is a production environment, and click deploy. And I'll just show you something that completed earlier. So what happens is the model will get registered automatically. As you can see, bank marketing, this is the model list. And you could also see the deployed model from the endpoints section. Once this loads up, for example, I could click on this bank one, and you could see the Swagger URI and take it from there. So that's basically AutoML from the UI. I'm going to just quickly pull up the chat to see if we have any questions, and we'll go from there. Looks like people are asking for the GitHub link. I think everyone has that. Um, so there was a question if you want to clarify time series, which option is better? Um, do you want to add more details about that question? Are you asking about which algorithms are better? Um, so if you are trying to see on which algorithms are better when you're choosing forecasting, I recommend just giving it a run with your data set, and then you'll see which ones are performing better, and you could always go ahead and block the ones that are not doing so well. How do you call the model from a user interface? Um, so so you have a couple options here. So you could either go ahead and look at the deployed model. So like you could go ahead and inference either using Power BI or also Postman. So like there's a couple options for you, and I could share links on how you could do that. For this specific workshop, we're going to just focus on the training. So using automated ML. Let's see, any other questions? What's the best way to import a large data set into our Azure? So the question is, what's the best way to import a large data set into Azure? So there's a couple options actually, depending on where your data is setting. So like you could always bring it in right from SQL, wherever it is. If it's sitting in your local files, you could always put it into a blob storage. So there are some limitations in the data size that we currently support for automated ML, but when you're working with larger data, we recommend using our many model solution accelerator. If it's suitable for your experiment, you would be able to partition your data and build multiple models in order to get your predictions. So that's something out there. So I'm gonna go ahead and switch back to demo, and we're gonna start the second lab now. Um, I'm hoping that people got to set up their subscription and also their workspace. And you could go ahead and launch the AutoML UI run while I walk through the SDK one, or you could just go ahead and continue to watch this as a demo. So for the second demo, you would need to have the compute instance set up because that's where we're going to be using the notebooks. Um, and another thing you'll need to do is you're going to have to clone this GitHub repo. So I'm going to just show you all the steps you'll need to do. So let's start off by cloning that GitHub repo. So I'm going to open up. So from compute, you should be able to open up Jupyter Lab, which is what I'm going to do. And I already have it open here. So once you have Jupyter Lab open, I recommend opening up the terminal, which you could access by clicking on the plus sign at the top over here. So I'm going to click on terminal, and all you'll need to do is type git clone, and the link to the repo that I shared in the chat. I'm going to also paste a link to the repo again, just one more time so you can access it. And what this will do is it'll clone the notebooks for you. And I already do have all of this open. So let me see if I can pull it up quickly. So I have the TMLS open here. And so this is basically all the notebooks that we're going to be running through for this example. So let me go ahead and pull all of this open. So we're going to start off with lab part 2. And the notebook is actually labeled lab part 2 AutoML Python SDK. So you could go ahead and open that up once you have that ready. So, and for this example, we're going to be using the Orange Juice sales data set. And all the material you'll need for the demo for this specific notebook is already in this folder. So all you'll need to do is clone it and you'll have everything. So the first thing we're going to have to do once we open up this notebook is set up all the required packages. And that's what we're doing over here. And what we see over here is the SDK version. So we do have, for our Azure Machine Learning makes releases every 2 weeks. So I do recommend that you always look out and use the most recent version of the SDK to get the best experience. Right now, I'm using 1.16, and there should be a new one coming in another 2 weeks. So once I have all my required stuff set up, I could go ahead and call my workspace configuration. And what this does is it pulls up the subscription ID. So this is what you created earlier in step 1, the workspace. So this is the workspace name, which is what you created in step 2. I could see like the resource group and all the additional information about my workspace. So that's what this is doing. And everything you do is going to be happening within your Azure Machine Learning workspace. And that's why you're pulling in all that information. After you have all the required setup done, you could go ahead and set up your compute. And the workflow is very similar to how you did it with the AutoML UI, but this time you're just doing it with Python code. So the first thing that we're going to do is set up our compute cluster. And in this case, we're calling it OJ cluster. We're using a standard D2V2 compute with max nodes of 6. And you could go ahead and run this cell. And what happens is you will see it's creating. And then eventually, once you see a number, it's done. So this cell is complete. The next thing after I have my compute set up is I'm going to go ahead and set up my data and bring it in. And in this case, since we are using the OJ dataset, this is a forecasting problem. We're trying to predict sales. We will need to specify a time column. In this case, it's week starting. We're feeding in the file name. So in this case, .csv, which is already located in here. And we could see the data and what it looks like. So in this case, we are predicting quantity. So now what I'm doing in the next couple of cells is just cleaning up the data and specifying like the time series column names. In this case is store and brand. So store and brand are unique combinations that will help me identify the different time series in my data. So once I have that set up, I could go ahead and split my data into train and test. And that's what I'm doing here. You have the option to split it up differently if you want to, but this is how we're doing it for this example. And once our data is ready, we're going to go ahead and upload the data to our data store. We're uploading both the train data and the test data. So that's what I'm doing. And finally, we're going to just review it one more time, change it to a pandas data frame and give it a look. Once it's ready, we could go ahead and identify our target column name. In this case, we are predicting quantity. Another thing we're doing in here is some customized featureization, similar to how we are able to do it from the UI. This is how you'll do it with code. So in this case, we're dropping some columns. We're adding some column purpose. So setting up this CPW volume 5 to a numeric value. We're transforming some parameters. So for example, imputing quantity with a constant and filling the values with 0. Again, we're imputing the value income with the median for any of those missing values and imputing price with a strategy called FFfill. So once we have our featureization set up, we've done our customized featureization, we can go ahead to the training part. And this is where the AutoML settings come in. So in this case, we know the task is forecasting. We have a set of primary metrics that we could choose from. I'm just going to show you guys the actual AutoML configuration over here. So we specified the task type. We are calling in the time column name, forecasting horizon, and time series ID that we specified earlier in the top of this notebook. We're calling in the label column name that we set up as well, which is quantity in this case. We're specifying that we want to only run this experiment for 0.25 hours. And then we're also feeding in our featureization configuration that we set up just right now. So once we have all these set up, and just a heads up, there are some additional settings that you could play around with just to customize your AutoML run, but we're going to go ahead and run it with this. What we see here is we just launched our remote run. We have access to the run from the studio, which I will click in a minute, but we could also see these details right from this page. So we could look at the transparency. So what happened behind the scenes with featureization. So in this case, we see that the raw feature name was advert, type detected numeric, and did we drop it? No, and all that additional details about every individual feature in this data set. So that's how you access the feature transparency. Before we access the forecasting bit, I will open up this run from the studio so that you get to see how the experience is exactly similar to running it from the UI. So right now we see this completed run for the AutoML OJ forecasting. We see a recommended voting ensemble. We see the metric value for normalized mean absolute error. We could always explore the additional metrics as we did before. We could see the data guardrails from the guardrails tab once it loads up. We could always review the additional models that were explored. So example, voting ensemble in this case is a recommended one. So I'll click on that. And we could see the explanation for that voting ensemble model. So this is the whole process from running it from the UI or from the notebooks, the output would always be the same. You could always access it from your studio or from the notebooks directly. And then you could also see the metrics and stuff. You have the option to go ahead and deploy the model right from the notebooks, or you could just go ahead and do it from the UI. I'll just show you those steps as well. So what we're doing now is just retrieving the best model. In this case, it was the voting ensemble. Taking a look at that. We've already reviewed this transparency, so I'm going to skip that. Now we're going to go ahead and forecast and do the predictions. So we did hold back the test data from earlier. So we're going to use that to predict the values. So that's what we're doing over here. And then finally, we could go ahead and evaluate our model using the metrics and stuff right from the notebook. You have the option to just review it from the studio if that's something you prefer. And finally, you could operationalize your model. So this is the whole deployment part. In this case, we're going to go ahead and deploy the model to Azure Container Instance. And that's what we're doing here, all with code. So in this case, specifying it's an ACI configuration, identifying the compute you're going to use, give it a name, in this case, AutoML forecast. And then in the end, what you would want to do is call the service, and you could just do that from the code as well. In this case, we could see the forecast right here per store and brand. And that's basically how you run it end to end using the notebooks. So you could definitely see the similarities from using the notebooks and the UI. Just if you prefer using code, I recommend using the notebooks. If you want to create an experiment quickly with just a click of a button, I recommend using the UI. Let me know if you have any questions. And if you want to just like run through the example right now, I'm happy to like just sit on the call and see if you have any questions. Let me just skip to this slide so then you have the resources page. So if you do have questions about automated ML or want to access our docs, go ahead and visit these links on the slide right now. If you have questions specifically about automated ML, I'm going to type our email in the chat so you could just directly email us. So it's askautomatedml@microsoft.com. So there's a question about, can we use Azure Databricks and Spark? So you can use automated ML on Azure Databricks, and we do have a sample notebook that you could access. Let me share the links to the sample notebook as well. I'll put it all in the chat. Just so like you could do the same thing running automated ML right from Databricks if that's something you prefer. I'll just quickly open up. I'll paste the links to the sample notebooks in our chat. So I will quickly share my screen again, just so that you have. So depending on your scenario and what you're trying to do, we do have a lot of sample notebooks for you to get started. So if you're doing a classification scenario, you could use one of these classification notebooks. Forecasting, we have a couple, and regression as well. Now, you do have the option to run this locally or remotely. I recommend following the steps from our this GitHub repo that I pasted earlier, so that you could just give it a run, get the idea of how automated ML works, and then figure it out for your own scenario and see how you could bring in your own data and start running automated ML. So there's a question, when you use a notebook, are you training the model on the notebook or calling an API and executing it in the cloud? We're actually training, so we're using a compute. We are calling a separate compute and training in that compute. We're just using the notebook. The notebook is running on the compute instance and the training is happening on another compute. So let me show you my screen quickly one more time. So in the compute section, you'll see compute instances, and we're using the compute instance to run the notebooks. We have compute clusters, and these are the computes that we're creating along the way, let it be in the notebook or when we're using the AutoML UI to do the training. So we're using two different computes here, if that makes sense. And yes, you can train locally. There are some features that are not available when you're training locally, but you do have the option to do that. And feel free to keep your questions coming. I will be here till the end of this call. Are evaluation metrics like ROC and confusion matrix available? Yes, they are actually. I'm going to point you to the docs actually, so then you can see all the metrics that are available. Let me pull that up and I'll paste a link in our chat. So I'm pasting a link to our understand your metrics, charts and metrics doc in our chat right now. And basically, just a heads up, all our Azure machine learning docs can be accessed from that same link that I just sent to you. If you have like any questions about different areas that were not covered today, so today I only covered automated ML, but if you're interested in like designer, in ML ops, or it could be about just like parallel run step or other parts of the machine learning workflow, feel free to access our docs to see how you can get started. In terms of the charts and metrics, to answer your question, these are all the metrics that we currently support. And we also do talk about the different charts. So confusion matrix, what it means, what's a good score versus not. So yeah, all of that information you could find here in the docs. Are there any tutorials on how to train locally? Yes, there is actually one. Let me just pull up this link over here. See, sorry. Let me open up the machine learning notebook quickly for you. So in the link I pasted earlier, you'll see this local run classification credit card fraud. And this is an example of how you can do it locally. And I'll paste a link to that as well. So we handle large data a little differently. So we do have specific algorithms that we use to train large data, depending on how large your data is. Again, so depending on like, just let me know how large your data is. And we could work with you offline onto supporting your scenario specifically. Let me know if you guys have any other questions. I will be here. So yeah, I do recommend that you all explore the docs as well, just to get an understanding of what else Azure Machine Learning currently supports, and to get a better picture of how you can bring in your solution and support something end to end. And all our automated ML docs, let it be for the using the Python code or the interface, can be found here. If you have specific questions about like featureization, what's happening behind the scenes, how is all of that done, you could access it from the featureization doc. So yeah, definitely check it out. And if you have any additional questions outside of this, feel free to reach out to us at the email I provided earlier. Does Azure have online tutorials on AutoML's workflow? So we do have something called MS Learn. You would be able to find an AutoML tutorial there. In addition to that, you could find tutorials right in the docs as well. So under the tutorials tab over here, you'll see automated ML UI. You could go ahead and click on that. And we also have a Python one. So depending on whichever workflow you're trying to take, you could try it from here. And of course, the sample notebooks also are pretty guided. We do have end-to-end steps on what's happening. So these are things that you could use to get started. So if we don't have any other questions, I'm guessing we can end early. There's a question on, can cost table be applied to confusion matrix? I will need to actually look into that one. All the details about what you can do with confusion matrix is in that doc that I sent earlier. As far as I know, I don't think it can be, but we can chat offline. So there's a question about, can you share your views and plans for drag and drop? If you're talking about the designer tool, so what's great about the designer tool is that it already has, so let me just open up ml.azure.com. It has a way for you to get started on your own. So as soon as you have your workspace set up, if you click on designer, you'll see some easy getting started samples. So we have some pre-built models, and depending on your scenario, you could just go ahead and click on one of these and get started. So I'm not the program manager working on designer, but if you have questions about it, I'm happy to connect you with that person. There's a question about, can I get code after creating model using drag and drop? So yeah, there is a private preview feature currently out there for you to generate the code from a designer run experiment. If you are interested, I could share that information with you. Just reach out to me. So I'll place my email here as well for anyone who wants to reach out about any follow-up questions. Um, and I can connect you if you do have any follow-up questions. I'll put it in the chat. One sec. Cool. So if we don't have any other questions, I guess thank you so much for joining. And remember to check out our docs and also the GitHub repo with all the machine learning notebook examples. And if you do have any questions, feel free to reach out to me at my email, anumamah@microsoft.com, or specifically if it's about automated ML, feel free to reach out at askautomatedml@microsoft.com. Thank you so much for joining me today.